Okay, 28 can be factored as 4 times 7 because 4 is a perfect square, and when you square root it, it becomes a 2. So this is 2 root 7. This is not a simplified fraction because you can't have a radical in the denominator. So we're going to multiply by root 3, so we have to do that on the top as well. And you get that, and then you cancel. 3 goes into 3 once, and into this twice, so we end up with 2 root 3. This is a perfect square, and this is a perfect square, so you immediately just get 5 over 4. When we multiply these, we're going to multiply the numbers outside the radical to get 8, and then inside the radical, 2 times 6 is 12. 12 can be factored as 4 times 3, and we square root the 4 by bringing it out. It becomes a 2, and this 2 multiplies with this 8 to give us 16, and we're left with the square root of 3. To solve this by substitution, we're going to take what y is, and we'll plug it into the other equation. So we have 2x minus 3y equals negative 1, and y is x minus 1. So we'll distribute that negative 3 and get negative 3x plus 3 equals negative 1. 2x minus 3x is negative x, and we'll bring over the 3 by subtracting it. Negative 1 minus 3 is negative 4, so x is equal to 4. Then I'm going to take this and plug it in. You can plug it in either one, but this will be the easier one. So you have y is equal to x minus 1, which is 3. So our ordered pair is 4 for the x and 3 for the y. Make sure you put it in order. Okay, to solve this by elimination, we can bring the x's to 14 or the y's to 24. I'll just get rid of the x's by bringing them to 14. So I'm going to multiply this top equation by 7. I'm multiplying by 7, and we get negative 14x plus 42y is equal to negative 35. And by 40, I'm sorry, where am I? I'm multiplying 7 by 6, and I get 42. What did I just do? Okay. All right. And then I'm going to multiply this bottom equation by, I want to get to a positive 14, so I'm going to multiply by negative 2. When I multiply that by negative 2, I'll get positive 14x minus 16y equals positive 10. And I'll add these together, and the x's are equal but opposite. They go away. These add up to positive 26, and this adds up to 52. So I'll divide by 26 and get y is equal to 2. Now you can take that and plug it in anywhere you want, but I think this is probably the easiest place right here. So putting in the y is equal to 2 there, I'll get negative 2x plus 6y, and y is 2, is equal to 6. So negative 2x plus 12 is equal to 6. I'll move the 12 over, and I'll get negative 2x is equal to 6 minus 12 is negative 6. And dividing by negative 2, I'll get x is equal, there's a negative there, x is equal to positive 3. So the answer is going to be 3 for the x and 2 for the y. This reduces to 1/4. And this is negative 4 over 1. They're opposites because one is positive and one is negative, and they're reciprocals. Opposite reciprocals are perpendicular. These are the exact same. When you have the exact same slope, these are parallel. This here reduces to 1/4. This is 1/4. Those are the same, so these are parallel. These are opposites, but they're not reciprocals. So they're not identical, so they're not parallel, and they're not opposite reciprocals, so they're not perpendicular, so these are neither. Okay, if you remember that this is a 5, 12, 13 is a common right triangle, you can see that this is 5 right off the bat. But if you're not certain about that, or if you just want to double check your work, x squared plus 12 squared, That's the sum of the squares of the legs is equal to the square of the hypotenuse. That's Pythagorean's theorem. You move the 144 over, and you get 169 minus 144 is 25. You square both sides, and you get x is equal to 5. These are the legs, so the sum of the square of those, so x squared plus 5 squared is equal to the square of the hypotenuse. I'll move this over by subtracting it. 100 minus 25 is 75, so x is equal to the square root of 75, which I'll write as 25 times 3. And I'll do that because 25 is a perfect square, and we can take it out, and it becomes a 5. So our answer is 5 root 3. All right, if these are the same, then this is a 45, 45. Oh, we're missing our 90 here. That's a 90. So this is a 45, 45, 90. So this is root 2 times that. So this is simply 8 root 2. Okay, if this is 8, then this is 8. And then now we have, these are the legs of the triangle, and that's a hypotenuse. So 8 squared plus 15 squared is equal to x squared. 64 plus 225 is equal to x squared. This is 289 is equal to x squared. So x is equal to the square root of 289, which is 17. All right, this is the hypotenuse. So the sum of the squares of those, which is 6 squared plus 12 squared, is equal to x squared. 36 plus 144 is equal to x squared. This adds up to 150, 180 equals x squared. So x is equal to the square root of 180. And 180, let's just break it down. This is 2 times 90. This is 9 times 10. And this is 2 times 5. So I'm going to write this as x is equal to the square root. I'll write this as 2 squared, that's this and this, times 9 times 5. When I take out a 2 squared, it becomes a 2. When I square root the 9, it becomes a 3. And I can't do anything about this. But on the outside, I have 2 times 3, which is 6. And on the inside, we're left with that square root of 5. Because this is a square, and it tells us this is a square, all sides are equal. So this is also x. So here's our triangle. The sum of the squares of the legs, so x squared plus x squared is equal to 8 squared. 2x squared is equal to 64. I'll divide each side by 2. So x is the square root of 32. And the square root of 32 I'll write as 16 times 2. And you can take out the 16 by square rooting, and it becomes a 4. So you end up with 4 root 2. Okay, the sum of the squares of these, so we have 5 squared plus 3 root 2 squared is equal to x squared. So 25 plus, now when I square this, I go square both parts. So I square this and get 9, and I square this and I get 2. And 9 times 2 is 18. And so this is 43. So x is the square root of 43. And square root of 43 can't be simplified, so that's our answer. All right, this is a 30, 60, 90 triangle. And if this is the hypotenuse, this right here is twice the smallest side. So this right here has got to be 9. And then the longer side is root 3 times the shorter leg. So this is 9 root 3. Okay, here this is obviously a 30, 60, 90 triangle. For the legs, the shorter side is always the side touching the 60. So this side touching the 30 is the longer leg. So x is equal to this times root 3. So x is 4 root 3. Okay, this is a 90-degree angle, and these are the same, so this is a 45, 45, 90. That means the hypotenuse is root 2 times that. So this is simply x is 9 root 2. If these are the same, and this is 90, then this is a 45, 45, 90 triangle, and this times root 2 is 10. So let's just write that down. X times root 2 must be equal to 10. So to solve for this, I'm going to divide each side by root 2. So x is equal to, now I'm going to simplify this fraction because we can't have root 2 on the bottom. So I'm going to multiply the bottom by root 2 and the top by root 2. And in the numerator, we'll get 10 root 2. And the denominator will get 2. And finally, we'll cancel. 2 goes into 2 once, into this 5 times. So this is 5 root 2. All right, this is a 30, 60, 90 triangle. So this is the shorter side, which means that this is half of x. Well, let's do it off of this. This times root 3 is equal to this. So this is 3 divided by root 3. So this is 3 divided by root 3. But that's not a simplified fraction. So I'm going to multiply top and bottom by root 3. And I'm going to get that this is 3 root 3 over 3, which is just root 3. And hopefully you're able to see that, because if we take root 3 and we multiply by root 3, we get to that. Anyway, x is always double the shorter side. So x is equal to 2 times this, which is 2 root 3. The hypotenuse is double the shorter side. In order to determine what type of triangle this is, I need to know all 3 sides. I know this, so I need to know this. Right now, I only know this, so I have to find this. Okay, so first of all, I'm going to find this, and we'll call this x. So x squared plus 15 squared is equal to 17 squared. So x squared is equal to 289 minus 225, which is 64. So x is the square root of that, which is 8. Now, this is 8, so let me write that in. And we need to know this, the y. Well, this is a right triangle, so this squared plus this squared is this squared. So I have y squared plus 8 squared is equal to 10 squared. Y squared plus 64 equals 100. So y squared is 100 minus 64, which is 36. So y squared is, y is 6. Okay, so now this right here is 6. If this is 6 and this is 15, this entire side from here to here is 21. Now, what I need to do to find if this is obviously the longest side. So in order to find what type of triangle that is, I have to compare 21 squared with 10 squared plus 17 squared and find out what relationship this is here. So 21 squared, I just used the calculator, that's 441. 10 squared is 100. 17 squared, that's 289, but I'm just going to double check. So 441, and this is over here, adds up to 389. 441 is greater. So since this side is greater than the sum of the 2 smaller sides, we have an obtuse triangle. First of all, this is a possible triangle because the sum of the 2 smaller sides is bigger than this. So we want to compare this with those. So in other words, what we're going to do is we're going to say 9 squared, 7 squared plus 7 squared. 9 squared is 81. This is 49. This is 49. 49 plus 49 is 98. 81 is less than 98. So because it's less than, this is an acute triangle. First of all, this is a possible triangle because 5 plus 7 is greater than 10. So now this is the longer side, so I'm going to compare that 10 squared with 5 squared plus 7 squared. 10 squared is 100, 5 squared is 25, 7 squared is 49, 25 plus 49 adds up to 74. Because 100 is greater than 74, this is an obtuse triangle. Okay, if you're not sure which is, we know that this is bigger than the 4, but if you're not sure which is bigger between this and this, just stick this in your calculator. 4 times the square root of 3 gives you about 6.9. So I know that this is shorter than this. Then 6.9 plus 4 is bigger than 8. So I know that this is a possible triangle. But I'm going to compare these two sides with this. So 8 squared, I'm going to compare that with 4 root 3 squared plus 4 squared. When I square this to get 16, I square this to get 3, and that's going to add multiply to 48. So this adds up to 5464. When I square this, I get 64. Because these are equal, we have a right triangle. Okay, when I'm just judging whether this is a triangle or not, 21 plus 7 is 28, which is smaller than that. So these three sides cannot make a triangle. So this is not a triangle. If I'm going to draw the medium of BD, I know that B is one of the points, so the D must be over here. So I'm going to pick a point halfway through, and I'm going to call that point D. And I have to show that it's a median by doing that. And then I'm going to take my ruler and draw from B to D. That right there. Make sure you put this and this here to show that that's the median. The altitude of IK. Well, first of all, this is I. So I'm going to drop this down to this side. The problem is, the altitude's got to hit this at a right angle. It's not going to hit it at a right angle inside of the triangle. So the first thing I'm going to do is extend this line. I'm going to take a ruler, and then I'm going to draw a dashed line because this is not part of the triangle. And then I'm going to draw a dot from here to this and intersect or hit it at a perpendicular right angle. So this, well, let's do the best I can here. I want to make sure it's at a right angle. Something like this right here. And that, you have to show it's a right angle by doing that. And then you have to call this point right here, point K. So this here is the altitude IK. And it's got to hit, again, this line here at a right angle. The perpendicular bisector of AB. So first of all, this is AB. So I'm going to eyeball a point halfway in between, but I have to show that that's halfway in between by doing this. And then I have to, at a right angle perpendicular to this, I have to draw a bisector. And I'll put arrows on either side of it. And I have to show that it's perpendicular. I can't just be an eyeball thing. I have to show that by doing that. So you need this, this, and this to show that it's a perpendicular bisector. The perpendicular bisector of DF, well, here's DF. A point halfway in between is right about here. Perpendicular to this is straight up and down, like this. I have to put arrows on either side, but I can't leave it like that. I have to show that it's a bisector, first of all, by doing that. And I have to show that it's a perpendicular bisector by doing that. Okay, I'm going to plot these points. Negative 5, 2 is negative 5 in the x. Oops, I'm sorry, 2 in the y, so it's there. So that's our point D. And then point O is negative 1 in the x and positive 8 in the y. So that's the point right here. And that's O. And finally, G is 5 in the x and 4 in the y. So that's the point right there, and that's G. Now I'm going to take my ruler and connect those points. Okay. Now, in order to show that it's an isosceles triangle, I need to show that this side and this side are the same length. So let's look at the length of DO. The length of DO is the square root of the difference of the x's. So this is this minus this, and it doesn't matter which way you subtract. You could go this minus this or this minus this. Because you're about to square, it doesn't matter. So I have -1 minus -5 squared plus 8 minus 2 squared, which gives us the square root of 4 squared plus 6 squared, which is the square root of 16 plus 36, which is the square root of 52. Now I could simplify that, but all I need to show that this is equal to the other side, so I don't need to simplify this, at least not yet. All right, now I need the distance OG. So OG is the square root of, let's see, this minus this, so 5 minus -1, which is 5 plus 1 squared, and this minus this squared. So we have 4 minus 8 squared, which is the square root of 6 squared plus a -4 squared, which we already know that this is 36 and this is 16, so this we know will be the square root of 52. I don't need to simplify it because I can see that these are the same. So we know that DO is congruent to DOG. In other words, this is the same as this. Okay. Now, in order to see that this is a right angle, I need to see if this angle has an equal but opposite slope to this angle. So let's find the slope of DO. The slope of DO is y2 minus y1, 8 minus 2, over x2 minus x1, -1 minus -5 or plus 5. This will be 6 over 4, which is 3 over 2. The slope of, that was the slope of DO. The slope of OG is y2 minus y1, 4 minus 8, over x2 minus x1, 5 minus -1, which is 5 plus 1. So we have -4 over 6, which is a -2/3. These are opposite, one's positive, one's negative, reciprocals. You flip it upside down, you get that. So we know that OG is perpendicular to DO. So therefore, since they're the same, tells us that this is an isosceles, and because these are perpendicular, this tells us that this is a right triangle, right angle there. So therefore, DOG is isosceles right triangle. Okay, let's graph this. -6, -4 is -6. Oops, what did I just do? -6, -4 is over there, and that's H. A is -2, +4, which is there. That's point A. And T is +6, -4, which is there, and that's a T. And I'm going to do this. Okay, now that's graphing AD. Oh, I'm sorry, graph the median AD. So the median's coming off of here, and it looks like it's going right there, but we should double check that that is the midpoint between H and T. Because it's all on a straight line, I can actually just count it off. But if you're not sure about it, the x value of the midpoint, let me do this in green. The x value of the midpoint is the sum of the x's, and this is between h and t. So I'm looking at this and this. So negative 6 plus 6 over 2, which is 0 over 2, which is 0. The y value of the midpoint is the sum of the y's, this plus this divided by 2. So negative 4 plus negative 4 over 2, which is negative 8 over 2, which is negative 4. So the midpoint is 0 for the x and negative 4 for the y. So this is the midpoint right there. So, and I can show that by doing that. And then I draw a line from there to there. Graph the altitude HE. So here's H, so E is going to be over here. And I need to hit this at a right angle. So in other words, I need to know the slope of this, so I know the slope that's perpendicular to this. So the slope of AT is equal to y2 minus y1. This is A and T. So y2 minus y1, negative 4 minus 4 over x2 minus x1. 6 minus negative 2 is 6 plus 2. This turns into negative 8 over 8, which is negative 1. So the slope of the perpendicular is the opposite reciprocal. The opposite of this is positive. The reciprocal of 1 is still 1. So that's the opposite reciprocal. So from this point, we're going to rise 1 and run 1. This is like 1 over 1. So I do that. So that's the point right there. And then I'm going to draw from there to there. Just trying to lay this down nicely. And I got to show that this is a right angle by doing that. And I have to label this point right here. This is HE, so I have to label that point E. Okay, the perpendicular bisector of HA. So this is HA. I need to have something come through this. So I first need to know the midpoint of HA. It looks like it's right there, but just let's do this mathematically. The x value of this midpoint, now I'm talking about H and A. Oops, I have to make this smaller. H and A. So this is negative 6 plus negative 2 over 2, which is negative 8 over 2, which is negative 4. The y value of the midpoint is negative 4 plus 4 over 2. So the midpoint is negative 4 for the x and 0 for the y, which is in fact right there. Now, I need to know the slope of this so I can know the slope of the perpendicular. So the slope of HA, here's HA, is y2 minus y1, negative 4, that's positive 4 minus a negative 4, which becomes plus 4, over negative 2 minus negative 6. Negative 2 minus negative 6 is negative 2 plus 6. This turns into 8 over 4, which is 2. So the slope of the perpendicular is the opposite, so negative, and then flip it upside down, so you get negative 1/2. So starting from this point right here, negative 1/2, starting from that point right there, negative 1/2, I go down 1 but run 2. So that's the point right there. So now I'm going to draw this. And I'm going to put arrows on either side. Now I have to make sure that I do this to show that these are the same distance, so that that's the midpoint. And I need to do one more thing. I need to do this to show that that's a right angle. And that's it.